Okay, uh, greetings everyone and welcome in to my channel. I am Professor L and I am going to be hosting a live math session for Math Help, and this is free for anyone. So if you want to come and do some math with me, then tune in. In the meantime, I am going to be presenting, practicing on my board and showing how to sketch the graph of a function called the cosecant function. And I'll be informally discussing the cosecant function and explaining exactly what it is. And we'll be getting a really good look at, hopefully, if I'm able to sketch it, that is, a really good look at the behavior of this graph and a better understanding of the domain and the range. So recall yesterday, now part of my informality is that sometimes I will, I'm practicing on my board and I'm relearning the math, and it's kind of like not riding a bike for a while and you get back on, it's kind of rough in the beginning. And yesterday I had to go back and I had to do a little bit of research and digging and looking at the relationship between tangent function and its inverse function, arctangent, and what's going on at these asymptotes, these values. Because while the domain and the range of this original function here, did I erase the domain and range? Here it is, I boxed it. You notice that we had to restrict the domain between this asymptote and this one. And we had to do that to make it a one-to-one function so that we could take and find the inverse of it. Now, when you invert this function, it produces a function, a unique original function. Sorry, it's not original. It's unique, and it's a separate function that has a domain that has infinity for a domain. That means that every real number that you plug in will return a value. So when you are trying to plug in values and have it return an angle, however, the angle measure at pi/2 creates another asymptote in the graph that is horizontal here, and this function is trapped between the bounds of returning. So while it'll take in an integer at any value, it's only going to return an integer, or excuse me, an angle between the values of -pi/2 and pi/2. So it will not ever return an angle of pi or any of these other values of these angles that are in quadrant 2 and 3. So that was kind of throwing me through a loop, because while I realized that, I was trying to figure out, well, how would I plug in a value, and it'll generate a value out here at pi/2, and it will for every value on the graph to infinity. However, it's going to give you an undefined value. It's not going to return an angle at -pi/2 because this asymptote, these two asymptotes right here. So I just thought that that was worth a minor explanation. And I guess I'm always messing up these figures of speeches, but a minor caveat, I think I'm saying that correctly, would be that this is very informal, and it's also like it's a somewhat of a vulnerable thing, because I'm not super genius and I don't have special mathematical powers. All I do is I have a love for mathematics. I enjoy doing it, and thinking about these topics in depth. And so hopefully some of you all do as well. Very good. Anyway, I am going to go ahead and erase this and get into the cosecant function. Hopefully everyone's doing well. And the cosecant function, recall, I know I say recall a lot, but the cosecant function is a reciprocal function that is found when you find the reciprocals of the sine function. So there are three reciprocal functions. So we have cosecant, we have secant, and we have cotangent. And they're simply found by taking the inverse, or not the inverse rather, but the reciprocal. So we'll just go ahead and label this and switch out the marker because it's really squeaky. And the cosecant function. If you have questions about your math, and I can answer it, I'd much rather be working your problems. So maybe you have one and you want to post one in the chat. And if not, maybe you think of a subject that you would like to see, and I can kind of research and maybe work on trying to do a halfway decent job of presenting it. All right, so y equals cosecant x. And I haven't graphed this yet, and I haven't practiced graphing this. This is just me playing around, trying to get used to working on the board in front of a camera. That's challenging. All right, so we have cosecant. We're going to have to get a couple of things here. And go ahead and get our table set up. X comma y. So what this function is doing, and we'll go ahead and put y equals 1 over the sine x. And we can just, because recall, this is cosecant is the reciprocal of sine. And so we're going to have to get, how many values do we want? Let's see here. Go ahead and get our graph sketched, our Cartesian coordinate system here. And see what this cosecant function is doing. And I just remembered that the last time I sketched this graph, I did it a lot easier by doing a real quick sketch of y equals sine x. So I'm actually gonna, let's see, back up here. I just realized. We'll do y equals sine x here. So I don't have to erase all that. Sine x. And I really don't need a table for sine x because I have it memorized, but just for educational purposes, we'll go ahead. And what we're doing is we're going from 0 to 2 pi. So we'll have 0. We'll cut this graph in half. We'll say that's pi over 2, and we have 3 pi over 2. Okay. That's over 4, sorry. If you're ever in doubt and you don't have the unit circle handy, you can always just say pi plus 2 pi, use that midpoint formula, and then divide it by 2. So that's 3 pi over 2. And that's right, because that's 270. Okay. So we'll go ahead and put our table values for our domain. We got pi over 2, pi, 3 pi over 2, and 2 pi. Okay. And recall the sine function at 0. Go ahead and draw my 4 corners at least. We've got 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. And so we have visually checking the cosine, or sine rather, of 0 degrees here is 0. And pi over 2, we're at 1. Pi, we're at 0 again. 3 pi over 2, we're at negative 1. And 2 pi, we're back to 0. So we'll go ahead and sketch these ordered pairs here. And we have 0, 0 on here. And what I'm going to do is I'm going to go ahead and I'm going to put sine. We'll put sine in a dashed line. And we'll do the cosecant graph in solid. And I might need to just make this a little bit bigger. Okay. We have 0, 0. We got pi over 2. Got to put our range in here. 1, negative 1. And we've got pi over 2 is at 1. So we've got pi over 2 comma 1, pi comma 0, and 3 pi over 2 is at negative 1. And then we're back to 2 pi at 0. And dash this. We've got this sine function, general behavior, 0 through 2 pi. And this is going to help us to sketch the graph of cosecant because we can just take these points for y equals, like we'll start here. So we have this cosecant x, and that is, by definition, that's 1 over sine x. And so we have 1 over, by definition, opposite over hypotenuse. And remember, when you divide fractions, you're inverting and multiplying that second term, so that it leads us to hypotenuse over opposite. Okay. So when we're trying to find cosecant, we're looking for the hypotenuse over the opposite. And so if we have the sine value, for example, this first value, so we have an undefined issue when we have 1 over the sine of 0 is 1 over 0 is an undefined value. So when we plug in 0 here, our cosecant graph is actually undefined. Yeah, plug in 0, undef. And then, so we have that value. And then we'll go to the next point. It's pi over 2. And so we'll do it here. So we've got cosecant y equals cosecant of pi over 2. And what it's doing is it's taking an angle into its domain and it's evaluating the angle and it's returning a value of a side length ratio. Okay, so it's giving you a range, a value in the range. So cosecant of pi over 2. And just because I want to make sure I trust, I'm going to go ahead. And if you want to use your calculator to check these, what you can do is you just take 1 over the sine function. And I just want to check it, make sure. Okay, it says cannot divide by 0 for the first one, so we're good. And then divided by 2 real quick. And it's saying it's 1. So when you plug in pi over 2, let's just see what this function's doing. That's y equals 1 over the sine of pi over 2. And so 1 over the sine, so 1 over the sine of pi over 2 would be 1 over 1, which is going to give me 1. All right, good. And so that is a value that's on the graph. Let's go to pi and see what's going on at pi. And see if this will help us to also write the domain and range of the cosecant graph. All right, so let's see what's going on at pi. Okay, so y equals the cosecant of pi. That's 1 over the sine pi. So that is 1 over the sine of pi with 0. So we're going to have another undefined value, cannot divide by 0. And really, when we do the secant function tomorrow, what I'm going to try to do is I'm going to try to get some more points in here. This is just the first time that I've messed around with the reciprocal trigonometric functions in a while. And so this is a good getting my feet wet here experience, because it's been a minute. All right, so we got undefined. And so we'll go to 3 pi over 2 and figure that one out. Y equals cosecant of 3 pi over 2. Again, this is good to practice writing the notation and familiarizing yourself with all of these abstract symbols, because the more that you work with them and you practice, you internalize this math, it'll start making more sense. Okay, it is pretty logically sound. It's one of the things I like about math. Okay, so we got sine of 3 pi over 2. It's just life gets busy, so it's hard to find the time and carve out time for something that. Okay, so we got 3 pi over 2, negative 1, so that we'll say negative 1 here. And so 1 over negative 1 is just negative 1. So we have this value, and that was at 3 pi over 2. Negative 1. And 1 more 2 pi. What do you suspect is going to happen here? Okay. So we have, let's see here, 2 pi, y equals cosecant of 2 pi. So this is y equals 1 over sine of 2 pi. And, you know, one of the quirks in my personality is that I make a lot of mistakes just for no reason at all. So sine of, oops, do I want to do that? Yeah, I do. Sine of 2 pi is 0. 1 divided by 0 is again undefined. Okay, good. So what's going on here is we're having all of these undefined values at these locations on our graph. So we're going to have to partition our graph at all of those values. There's one at the here on the origin right here on the y-axis. So we're going to dash that. I'm trying to get all these dashed. There's another undefined value at pi. So I'm going to do my very best. I'm trying to watch these videos and critique them myself and try to figure out, try to get better and not be lazy. And I noticed that my lines were getting a little loosey-goosey yesterday. So apologize about that. And to be honest, I'm doing the best I can here. All right, so where we got pi, and I'll go ahead and sketch this other one at 2 pi. Visually representing it makes a lot more sense when you get to see the graph of these functions too. At least just from my perspective, it's like it makes more sense to me why the domain is what it is and where it's restricted and these types of things. Right. So we don't have enough points in here, I just realized, to get a good idea of the behavior of this graph. So we might have to erase some of this and put some more points in here and see if we can't do a little bit better. But it has this point in common because we have pi over 2 comma 1 on the graph of cosecant. And what cosecant is doing is it's bound by these asymptotes. It's approaching these asymptotes. And so what it's doing is it's creating these parabolic looking things. But if you're ever stuck, if you're in say you're in a math exam and they're asking you if these values are on the graph, you can really quickly sketch this graph or even kind of think about it in your mind after you've seen it. Some of you all probably have the photographic memories. And if that's the thing, then you can, see where this function is living. And so it's actually got a really interesting domain and range. And let's see, the domain is going to be a restriction because every undefined value is not going to exist in the domain. It's just going to exist in between. And it looks like it's going from 0 to pi. So I'm going to try to write the domain without help. I'm going to try to do it without. It's one of those, maybe I'm not going to be able to. Okay, this is a lot of pressure. So the domain of it is one of these where you're not going to be able to include it. And you're going to have to probably use a set notation 2n plus 1 divided by 2. No, it's not divided by 2. It's just times n times pi. I think this will do it. And then such that N is an element of Z. And you're going to have, yeah, it's going to have to be a set notation. And of course, I don't have my clipboard, so maybe I'll just look it up real quick. You got the internet at your fingertips. Yeah, it says integers. So how will you write it in set notation? Okay. It says except for integers multiples of pi. So this is saying x is. All right, let me rewrite this. I was close. All right. And I want to put it up here kind of close to this. So it's saying the domain, and it's using set notation. It's saying x is in R. Oh, the reals. And I just don't have room. I'm gonna have to erase some stuff. X is in R. Maybe I'm gonna go ahead and erase this stuff right here. And this is good practice for me because it's like I think I know something, and then I realize it's been so long since. So it's X is in R. It's a pretty scripted order. And it's such that X is not N times pi. Okay, there it is. N times pi. And it says N is an element of this integers, the Z's. Transcript that and then end up with the curly brace. So this would be technical domain in set notation. And then the range is a lot easier for me to state. Range makes a lot more sense. What's happening is these values are on here. So what you're saying is, so you'll use a parentheses and you'll say in negative infinity, comma, bracket, -1, and then you're gonna use a bracket there, and then union, +1, comma, infinity. And you're gonna end it with a parentheses. And that is because the parentheses in this is interval notation. They both have their uses and functions. I prefer interval notation if I can get away with it, just because it's a lot easier to mathematically read for me. But it's a preference. All right. So we have the parentheses signifies that you're not including the value, and you know you can't include infinity because it's expanding. However, the -1 is, and I erased it, it's -1 here, is a point on the graph. So we're including it, and that's where this bracket comes in. And the range is not existing here, between here where we sketched the sine function. It's reciprocating it, and it's creating this rational function. And it's funny because a lot of things sound like how we mean, but rational functions are completely irrational. There's nothing rational about them, but it comes from the definition of rational number and the set of rational numbers. So anyway, so here's your domain and range of your cosecant function. Very good. And see if there's anything else that I want to talk about. All right. So we'll probably, unless somebody has a question, I actually see chats for the first time ever. So, yeah, I don't see any math questions though, so that's a bummer. Maybe someone will, throw me under the bus, the theoretical bus, and give me hopefully it won't be too hard at first. Go easy on me. But if it is something, I want to be helpful. And there's no sense in me having all of this math knowledge and just, tucked inside my brain. It's good for me to, get out of my comfort zone and come hang out with the camera. And, hopefully I'm not laboring in vain here. Because somebody has a question that eventually they will, um, you know, join the club and ask, maybe, or not. It's all right. Okay, so enough of that. And what I want to do is probably go ahead and finish graphing the next day or two with these reciprocal functions. And I'm going to try to spend a little bit more time on secant tomorrow, where I'll try to get a very good, much bigger graph, maybe some negative values in here as well. And maybe some more points also, so you can get a little bit better idea of what that secant function is looking like. Very similar to cosecant. It's just, it is a little different and it has a couple of things that are different about it, and we'll get to see that next time. And so, yeah, that's probably good for me. I realize it's only 30 minutes, but again, this is really good for me to just, even getting all of this together and spending some time in here with my board it's big, and I'm really excited for the opportunity to do it. So like always, thank you so much for watching my videos. And please, if you have a comment that's kind, obviously, and maybe possibly about math, I look forward to reading them. So again, I'll see you back here between 6 and 7 p.m. Central Time tomorrow. Bye.